Armor is one of the most ancient ideas and inventions of humanity. We cast it from bronze, from steel, even from Kevlar. But the ocean has been coming up with ingenious approaches to armor for hundreds of millions of years, crafting weapons and shields from the most hardy and bizarre materials known to science. Many of these materials still baffle scientists to this day. Imagine a humble limpet with teeth stronger than steel. Consider a deep-sea snail covered in iron plating. Now think about a humble sea star covered in its own naturally occurring chainmail. We'll be exploring these materials today, as well as the animals that create them, as these materials are being used in laboratories today to help inform new technologies and armor around the world. We'll also be exploring some of the limitations. The sea butterfly is one such example of an animal covered in very delicate armor that is now subject to dissolving through ocean acidification. If this interests you, make sure that you subscribe and like and let me know what you'd like to learn about next. This is The Curious Current, and let's jump in. Deep in the pitch black world of hydrothermal vents, where boiling hot mineral-rich water gushes from the seafloor, lives a creature so bizarre it feels like science fiction, the scaly-foot snail. Now, I've covered this animal before, and you can click on this link to go into a deeper dive of it, but it's worth covering again. At first glance, it looks like an ordinary sea snail. But look closer, and you'll see something no other animal on Earth has ever done. Instead of wearing a fragile shell of chalky calcium carbonate, this snail has built its armor out of metal, real metal. Its entire body is studded with tiny scales of iron sulfide, the same mineral that oozes from the black smoke or chimneys around it. These chimneys spew out water so toxic and acidic it would dissolve most life instantly. But the scaly-foot snail doesn't just survive here, it takes the very poison in its environment and reforges it into a shield. And the shield is no simple coat. The snail's shell is a 3-layered masterpiece. Closest to the body, a layer of calcium carbonate, like you'd find in most shells. In the middle, a thick, shock-absorbing organic cushion that acts like padding. And on the outside, a jagged armor of iron sulfide crystals, the same material miners once called fool's gold. The structure makes the scaly-foot snail one of the most heavily armored animals on the planet. It's as if evolution took inspiration from a medieval knight's armor, complete with padding, plating, and chainmail. When scientists tested this shell, they found it could absorb and dissipate crushing forces far better than many materials we've engineered. Imagine pressure equivalent to thousands of meters of seawater, combined with predators capable of drilling or crushing shells. Yet the scaly-foot snail shrugs it off. Even more astonishing, the snail's very scales, tiny overlapping plates on its foot, act like detachable armor. If a predator manages to grab one, the snail can just shed it, much like a lizard dropping its tail. It's a built-in decoy system, giving the snail a chance to crawl away. And remember, this creature doesn't photosynthesize, doesn't eat in the traditional sense. It relies on symbiotic bacteria inside its body that convert the toxic chemicals of the vent into usable energy. Its entire existence is tied to one of the Earth's most hostile environments, where heat, pressure, and poison meet. The scaly-foot snail is more than just an oddity. It's a symbol of life's ingenuity. An animal that took what should have been a death sentence and transformed it into armor. Evolution turned poison into protection, fragility into fortification. And in so doing, this humble snail built something so extraordinary that engineers today study it for inspiration. Because in one of Earth's most extreme environments, a tiny snail has outdone human armor design. Now, shifting gears, I'd like us to look into the humble limpet, as I've said. When you ask the question, what animal has the hardest bite in the ocean, most would probably say a shark, a crocodile, or maybe a barracuda. But no, the crown belongs to something you'd probably step over without a second glance if you're going tide pooling. It's the limpet. Limpets are those little cone-shaped snails you see plastered to rocks in the tidal zone, looking like bumps of stone. Harmless, right? They don't even have jaws. But inside their mouths lies one of nature's ultimate power tools, a tongue lined with hundreds of microscopic teeth. These teeth are built from nanofibers of a mineral called goethite, woven through a protein scaffold like steel bars set in concrete. This combination makes them pound for pound tougher than spider silk, tougher than Kevlar. In fact, limpet teeth are considered one of the strongest biological materials ever discovered. And what do they do with this record-breaking hardware? They scrape algae off bare rock. Imagine chewing through granite just to get your breakfast. That's the limpet's daily grind. Each tooth can endure immense stresses without breaking, even while grinding against solid stone under the pounding surf. Here's the astonishing part. Limpets don't just have one set of teeth. Their radula, the conveyor belt-like tongue that they have, is constantly growing new rows at the back while old, worn-down teeth fall away at the front. It's as if nature gave them an infinite supply of diamond-tipped drill bits, always fresh, always sharp. Engineers have tested these teeth in labs and found that their structure could inspire new synthetic composites, materials that combine lightness and flexibility with jaw-dropping strength. Imagine aircraft parts, medical implants, or construction materials built using the same design principles as limpet teeth. And yet, the animal itself is a grazer, not a fearsome predator, but a humble snail clinging to rocks, eking out a living in the danger zone of crashing waves. It's a reminder that in evolution, raw power isn't just for hunters. Sometimes the greatest feats of strength are hidden in the smallest, quietest creatures. So the strongest bite in the ocean doesn't belong to a shark, it doesn't belong to a crocodile, it belongs to the limpet, a tiny grazer armed with a mouthful of teeth so strong, they put our best materials to shame. And then there's the chiton. Imagine a flattened, armored sea slug slowly gliding across a rock. At first, it doesn't look like much, but take a closer look and you'll see something remarkable. Its back is covered in 8 overlapping plates of shell, linked together like the segments of medieval armor. This creature is literally wearing flexible chainmail. This is another creature that I've covered in a previous video, so if you'd like, click the link on the screen now. That said, I left out a key detail when I made that video. Its real secret weapon isn't on its back, it's in its mouth. Like limpets, chitons scrape their meals with a radula, a conveyor belt tongue lined with hundreds of microscopic teeth, and these teeth are strong. But here's the twist. Those teeth are capped with magnetite. Yes, the same iron oxide that makes up the needle of a compass. Their teeth are literally magnetic. Magnetite is one of the hardest, toughest, naturally occurring minerals. And in the chiton's mouth, it turns their radula into a row of iron-tipped chisels. With this arsenal, they can grind away algae from bare rock, scouring surfaces where almost no other grazer can feed. It's a combination of brute strength and subtle engineering. Their shell plates give them the protection of armor, but because each plate is linked, the whole body can bend and hug the contours of stone. Flexibility and toughness in one package, a natural design problem we humans still struggle to solve. And those magnetic teeth, they're not just hard, they're perfectly structured at the nanoscale. Scientists studying them have discovered a blueprint for building materials that are not only strong but also durable, resisting wear and tear over time. Engineers are looking at chitons as inspirations for new coatings that could make machinery last longer, for medical implants that resist damage, and even for batteries that could one day store energy more efficiently. It's easy to overlook a chiton. They're small, slow, and glued to the rocks and tide pools. But beneath that unassuming exterior is one of evolution's great designs. A living tank with chainmail on its back and iron in its teeth. Nature found a way to fuse magnetism with biology, millions of years before humans even knew what a compass was. Now to shift gears, let's talk about the sea stars I mentioned at the beginning of this video. At first glance, a sea star seems soft, gentle, even a little defenseless. You can pick one up in a tide pool, feel its leathery skin, and think, there's no armor here. But under the surface, sea stars are anything but unprotected. Look closely, zoom down to the microscopic scale, and you'll discover that their bodies are laced with crystalline armor. Their skeletons are built from thousands of tiny calcite plates called ossicles, each one carefully interlocked to form a living lattice. Imagine chainmail, but forged from crystal. These plates aren't smooth or solid. They're riddled with microscopic pores and ridges, creating a structure that is both strong and astonishingly light. It's a natural engineering trick we struggle to achieve: strength without weight. The sea star can resist predators and crushing forces while still keeping the flexibility to creep slowly across the seafloor. If their skeleton were solid and heavy, they'd be trapped in place. If it were weak, they'd be easy prey. Instead, evolution gave them the perfect balance, rigidity where it's needed and movement where it matters. And here's where it gets even stranger. These calcite plates are not just lifeless armor. Sea stars can actively remodel their skeletons. Specialized cells can dissolve or redeposit calcium, allowing the animal to adapt its rigidity. In a way, their armor is alive, constantly maintained, repaired, and even reshaped as needed. To engineers, this is mind-blowing. Imagine an airplane wing that could heal its own cracks, or a bridge that could adjust its stiffness under stress. That's the promise hidden in the microscopic lattice of a sea star. What's light as foam but strong as stone? The answer was hiding in tide pools all along. The sea star reminds us that sometimes the most delicate-looking creatures are carrying some of the most advanced armor on Earth. Armor so clever, so efficient, that scientists dream of copying it for the future of aerospace materials, lightweight vehicles, even bio-inspired robotics. While we're still sketching designs on paper, sea stars have been walking around with them for hundreds of millions of years. Yet again, evolution is the greatest teacher. But not all armor lasts forever. Some of the ocean's most fragile defenders are also its most enchanting: the sea butterflies. Sea butterflies, or pteropods, are tiny snails that drift through the open ocean. Instead of crawling on the seafloor, they flap wing-like feet, fluttering through the water column like ghosts of glass. Their shells are exquisitely thin, almost transparent, delicate enough to catch the light like crystal ornaments. For millions of years, the fragile armor was enough. A tiny, thin shell of calcium carbonate kept them safe from small predators, while their drifting lifestyle made them a vital food source for countless others. From salmon to seabirds, from plankton feeders to whales, entire food webs depend on these tiny creatures. But today, their armor is under siege. As humans pump carbon dioxide into the atmosphere, much of it is absorbed by the ocean. There, it reacts with seawater, lowering its pH, making the water more acidic. And acidic water dissolves calcium carbonate, the very mineral these delicate shells are built from. In laboratory experiments, scientists have placed sea butterflies in water conditions predicted for the coming decades. Within hours, their shells began to pit, weaken, and dissolve. Imagine living inside a suit of armor that starts melting around you while you're still inside. That's the reality these animals face. It's not just about one small snail. Pteropods are a keystone species. They are fuel for salmon runs, sustenance for seabirds, and a crucial link for whales and other marine giants. If their armor dissolves, the collapse echoes upward, through the food chain, and into the ecosystems humans also rely on. For centuries, their fragile shells have carried them through ice ages, warming periods, and natural cycles of change. But the pace of acidification today is faster than anything their kind has faced in 50 million years. The sea butterfly is more than just a drifting snail. It is a warning, a symbol of how even the tiniest, most delicate creatures can hold the weight of entire ecosystems on their translucent shoulders. If their armor melts away, what else will follow? So in closing, from iron-plated snails to magnetic tongues, all the way to crystalline stars, the ocean is a master engineer. Its creatures build armor from minerals, metals, and crystals in ways that push the boundaries of what we thought was possible. But even the strongest armor can fail. The sea butterflies remind us that no design, no matter how ingenious, can withstand rapid change. The ocean has always been Earth's greatest laboratory. It has solved problems we are only beginning to ask, and now it's asking us for something in return. If you enjoyed this video, please consider liking, subscribing, and leaving a comment letting me know what you'd like to learn about next. I'm always interested in hearing from you. I'm Ned, this is The Curious Current, reminding you to always stay curious and stay current.